So in this lecture, we'll see how to apply the balance equation to derive balances for common reactors. So before we start, let's do a warm-up example. So this example applies the general balance equation to a reactor. So we aren't telling you much about this reactor. This could be any reactor. We're giving you some information about it, and we're going to use the general balance to solve this problem. So in this problem, we have a reaction. 2A plus B goes to 2C, and it's being carried out in some reactor. We're given inlet flow rates, so A, B, and C are fed at rates of 100 moles per second, 200 moles per second, and 50 moles per second. And then we're given this term for GA. GA equals minus 5 moles of A per second. So this is saying that species A is net consumed at a rate of 5 moles per second. And we need to determine FC. So let's start out by filling in the information on this diagram. So we know this is our inlet side, so we know some information about the species or the flow rates coming in. So we have FA naught. We know FB naught. And we know FC naught. Where again, I'm using the zero, the naught subscript to indicate these are inlet flow rates. Coming out, I don't know any of the flow rates. The reaction that's taking place is 2A plus B goes to 2C, and I know that GA is equal to minus 5 moles per second. So to solve this problem, I'm going to apply the general balance equation. So accumulation equals in minus out plus net accumulation. I'm going to do one thing right away, and that's to make an assumption that the reactor is at steady state. It's a reasonable assumption to make. I have no reason to assume that this is a non-steady state reactor. So now I can take my balance equation and I can write it and fill in terms to solve for the quantity I want. The quantity that I've been asked to solve for is this FC. So because of that, I'm going to write the balance. On species C. So rewriting, we'd say that 0, since we've assumed steady state, is equal to the flow rate of C coming in, FC naught, minus FC, plus the net generation of C, GC. So this term I know, and this is what I want to solve for. So I'm going to rearrange FC is equal to FC naught plus GC. GC I don't know, but I do know GA, and I also know that GA and GC are related by stoichiometry. And this is a key point that we'll get to, that we'll go over many times over the course of the semester, and we'll spend a whole lecture on coming up. But basically, when I have a chemical reaction, I can relate the rates of generation and consumption of the different species to each other through stoichiometry. So that's what I'm going to do here. I'm going to say my FC is equal to, and I can go back up here and look, FC naught is 50 moles per second. And so now I can take what I know. I know something about GA, and I also know that GA is related to GC by stoichiometry. So I'm going to scale GA by the stoichiometric ratio between C and A. So in this class, we denote stoichiometric coefficients with the lowercase Greek letter nu. That looks like something like that. And then I can fill in terms here. Five moles of A per second. Two moles of C divided by -2 moles of A. So notice here that I've written the stoichiometric coefficient of C. I've said that's a positive number, +2. And I've said the stoichiometric coefficient of A, that's a negative number, -2. So if I go back to my reaction, I see that the stoichiometric coefficient on both of those is 2. That's where the 2 comes from. When I do these unit conversions, products always have positive stoichiometric coefficients and reactants always have negative ones. So by convention, I've assigned a negative to this stoichiometric coefficient of A since it's a reactant. So this basically now allows me to solve my problem. The two negative signs cancel out, the two factors of 2 cancel out, so I basically have FC is equal to 55 moles per second. And that's my answer.